Okay, so in the last video we had stopped at the property of time scaling and linearity. Now let us move on to the third property, uh, which is time shifting property. So now if there is a function called as f of t, and if we take a Laplace transform, it will be f of s. Okay, now let's assume, what do you mean by time shifting? So there are two time shifting thing. One is left shifting and second one is right shifting. What do you mean by that? If we want to shift this signal by left or by right, that is what is nothing but time shifting properties. So first we will take the case of a right shifting property, which is represented by f of t minus t0. Matlab your time will be shifted by minus t0. So how it will be converted into frequency domain? It will look like this: f of s will be equal into e raised to minus s, which is the frequency domain representation, into t0, which is the time shifted by how much time. It is like that. Okay, so since here it is minus, so uh, here also you will find minus. Okay, similarly when we talk about f t plus t0, which is a left shifting property, so its Laplace transform will be equal to f of s into e uh, plus, which is, it is not t, it is plus s t of 0. Okay, now when I go ahead, when I take one example, you will understand it much better. Now let's take an example of Laplace transform of u t minus 2. Now if you remember, u of t is nothing but it is a unit step function. Now we are shifting it by minus 2. So what will be the change over here will be, so what is the Laplace transform of u of t is, it is 1 upon s. Okay, now what we have to do is we have to add minus 2. So once the minus 2 is added, it is given over here as minus 2 into t0. So it will be very simple that u t minus 2 will be equal to 1 upon s multiplied by this part, which is e raised to minus 2s. So t0 is what? T0 is 2. So t0 will be replaced by 2. So it comes over here. That's it. Okay, so this is about the time shifting property. Now time shifting was related to the left hand side. Now we are going to frequency shifting, which is s domain. So how it does happens is, now if f of t, the transfer function will be the Laplace transform will be f of s. Now let's take the frequency shift. Okay, so when we add minus s0, it will be s0 of t multiplied over here with the signal. Okay, here if it is plus s0, it will be minus s0 of t. So only thing which we have to remember is, when we need to shift the frequency, we need to multiply it by a exponential signal over here, and if we need to shift the frequency by plus 0, so it will be minus s of 0. Okay, so now let's take an example of find Laplace transform of e raised to minus at into cos omega t. So cos omega t का standard Laplace transform we already have. e raised to minus at क्या है आपका? वो shifting है. ठीक है, it is that shifting a by a, this signal should get shifted. Okay, so now see what happens when we take this example. So Laplace transform of cos omega t is equal to s upon s square plus omega square. Okay, now Laplace transform of e raised to minus at is equal to cos omega t. So now what we have to do, instead of s, what we have to put minus s0 or plus s0. Since it is minus of at, we have to put plus s0. So what is s0 over here is, it is a. So it will become s plus a upon s plus a the whole square plus omega square. So simply what we did, instead of s, we have to write s plus s0. For s0 over here, it is a. So we have written s plus a upon s plus a the whole square plus omega square. So this is the two properties which we have seen in this video. First property is time shifting property, and second property is frequency shifting property. In the next video we will be seeing the differentiation property, okay, which is a derivative base. So it is a little bit difficult, so I'll make a separate video for that.